The other day we looked at what we call a translation, where we slid it left, right, up, or down. Today we're going to look at a reflection, where we're going to take a point, or in some cases maybe an entire figure, and we're going to reflect it over a line of some kind. Okay. Starting off here, we have a point. Okay. So the first point that we're given is point P, and it's at -1, -5. Okay, and I'm going to call this one Q down here. I don't like using the same letter again, so I'm going to call this one Q, and it's at -1, 1, and I'm going to label it Q. So make sure you plot the point correctly first, because as I was helping people with homework yesterday, one of the biggest mistakes was plotting the original points in the wrong place. If you plot the original points in the wrong place, then guess what? When I move it, that new point is going to be in the wrong place as well. So that's got to be something we really got to be careful of. Now, here's what we're going to do today. This one says we're going to reflect it in the y-axis. And what that means is we're going to reflect it over the y-axis. So we know this is the y-axis, this is the x-axis. So right here, P, how far is P away from the y-axis? 1. It's 1 to the left, right? So when I reflect it, I'm going to go 1 to the other side of that line. So because we're 1 to the left, I'm going to move 1 to the right. And our new point would be right here, and we're going to call that P prime. That's all there is to it, okay? For the other one, Q, we are reflecting it in the x-axis. Okay, when I reflect it in the x-axis, I'm just kind of drawing the line in here so we can see where Q is in relationship to the x-axis. Right now, we can see that Q is 1 above, so when I flip it over, it's going to be 1 below. And I would call that Q prime. Okay? So we're saying how far is it away from that line, and then I'm moving it the same number of units in the other direction. Okay? What I will always tell you is these two are perpendicular to one another. Okay? Same thing here. If I drew a line, they're going to be perpendicular to that reflection line, because all we're doing is moving it either left or right or up or down over that line, depending on what that line is. Okay? So that's what we do when we do reflections. Now, what we're going to do today is it's not just going to be a single point. It might be like a whole triangle or quadrilateral, and we'll take the whole thing and flip it over a specific line, not just a single point. Okay, so what is a reflection? A reflection is a transformation that uses a line like a mirror, where you will reflect it over that line. This line is called the line of reflection. A reflection line, M, maps every point P in a plane to a point P prime, so that each of the following properties is true. If point P is not on M, so M is our reflection line here, right? And so we're going to do the same thing we talked about up above. I'm reflecting P over that line, okay? Now, this one happens to have a little bit of a slope to it, right? It's just kind of a line out in space. But as I was telling you before, when I connect P to P prime, these two must be the same length, okay? They have to be the same distance away from the reflection line, and it will also be perpendicular to that reflection line. Okay? Those two things will always hold true. Okay? Same distance, always perpendicular. Okay, if P falls on line M, then that's a piece of cake, right? Because where's P going to go? Nowhere, right? It stays right where it's at because it falls on the line. So you can't flip it over the line because it falls on the line. So if you happen to have a point that falls on the line, that point stays right where it's at, okay? Because it is falling on that line of reflection. here's some rules, and these are things that you can kind of memorize or remember. We may not get to all of these today, just because we have a little bit shorter time than normal, and then we'll finish up whatever we don't get to on Tuesday. When I look at the ordered pairs, if I have an ordered pair and I flip it over the x-axis, then my y value will be the opposite. Only the y value changes. The x value is still the same. My y value is the value that changes. If I flip it over the y-axis, my x value is going to change. Okay? If you look up here to the points that we just did, if I identified what q prime would be and p prime would be, p prime is at over 1 and down 1, 2, 3, 4, 5. So it's at 1, 5. One negative 5, I should say. Okay. Notice how the y value here stayed the same. But what happened to the x value? The x value is the opposite. Okay. If I did q prime, the order pair for q prime is -1, -1. So the x value stays the same. The y value is opposite. Okay? So that's what that rule is saying. Okay? One of the values will stay the same, the other one will change. Okay, the two that we have not looked at yet, the y equals x line and the y equals negative x line, we will look at here in a little bit and talk about what happens there. Okay? But notice here that the AB flip-flops. Okay? It just changes places. It was AB and now B and A change places. Here, not only do they change places, but they are also opposites. Okay? And I'll show you what that looks like here in just a little bit. Okay, so what I'm going to write up here is the opposite y value. This one is the opposite x value. Here, they switch places, and here they switch, and they are opposite. Okay, so I put a star by that because if you know the rule, it'll make those problems a lot easier. Okay, you can do the reflecting and all that without it, but it's a little bit more difficult to do in some cases. All right, let's do some examples. Talked about over here. Here's my y equals x line. The rule is switch the two variables, switch the two ordered pairs around. Okay, first thing we're going to do is we're going to plot these points and make a triangle. It says triangle ABC. I'm going to go ahead and do that on both of these because we're using the same triangle for both of these problems. We're going to go ahead and connect them together, make our triangle. All right, last chapter we talked about graphing lines, right? And when we graphed lines, we talked about what the difference between y equals and x equals was. And when I graphed a line of y equals 1, what does that line look like? It's horizontal, right? It's going to be a horizontal line, and it's going to go through 1. Okay, so when I do this, I'm going to do it in a different color so we can see it. And I'm going to make it like a dashed line.
Could you say that again?
And that line is my line of reflection. That's the line that we're reflecting this triangle over, okay? So we're going to take this whole triangle and we're reflecting it over that line. So I got to do 3 points. The easiest of those 3 is C. Where's C prime going to be? Right where it is. Because C lands on that line. So that's the easiest one to flip. That would be C prime. Okay, A, how far is A above the blue line? 2. So if I go 2 above, then I'm going to go 2 below, and that would be A prime. And then for B, B is 1 above the line, so we got to go 1 below the line. And that would be B prime. And if I connect those together, there's our triangle. Okay. As I look at that triangle, okay, is it the same shape and same size? Yeah, right. It's the same triangle, except we call that the orientation has been flipped. If I go around it clockwise, notice this is ABC. Now if I go around it clockwise, now it's ACB, right? So the order of the letters has been switched. It's orientated differently. We call that orientation has changed. But it's still the same triangle. It just sits a little bit differently, okay? So that's how a reflection is going to affect a figure, is it's going to change it on what we got. Okay? X equals 3. What kind of line is X equals 3? Vertical. Okay? So we're going to draw a vertical line through the x-axis at X equals 3. None of these points fall on that line. So all of them have to be reflected. So if we just go in order ABC, let's do A first. Where is A in relationship to that line? How far away? It's 2 to the left, right? So we got to move 2 to the right. That would be A prime. Okay, then let's go to B. How far is B away from that line? 3. Okay, 1, 2 to the right. So from that line, I'm going to go to the opposite direction. 2 to the left. And we'd call that B prime. Prime's always the new one. And then C is 1 to the left. So we're going to move it 1 to the right. And we call that C prime. And there's our new triangle. Okay. They're kind of overlapping one another. Okay. And when we do it, the two triangles should look like the same triangle, right? They're flipped, so the orientation is a little different, but the same shape, same size. It's not going to change those two things. Okay? Questions on those two? All right. Here's what I want you to do. Try doing this one here. Actually, try doing both of these. See if you can do both of those. Draw the picture, and then try reflecting it. Okay? I'll do it as you guys do it, and we'll see what we come up with. You might want to do it in pencil just in case you need to make a change. you guys doing this? You did both of them. All right. So if we look at these two, this is what we should have. Just, and I won't go through each individual point, but like for B, I'm going to go B over to the line, right? So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. It takes me 8 to get to the line. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, the opposite direction. Okay, we're just counting. That's all we got to do. Count to the line, count the other direction from that line. We did it for A, we did it for C, we did it for B. Down here, it's up and down because here's my line of reflection. So it's really important you put that line in the right spot. If you don't put the line in the right spot, then that's going to become an issue. Okay? All right, everybody feel pretty good about those? Any questions about the reflections there? All right, let's look at a rule that we... These two. Okay? This one's a little bit different, okay? Because we're flipping it over a different line. And we haven't talked about what this line is yet today. In this case, we have a segment, graph FG. So we're going to graph FG to start with. So we have 1, 2, which is G. Negative 1, 2, which is F. Okay, I'm going to connect those two together, and that's segment FG. We're reflecting that entire segment over a line. The line that we are reflecting it over is the line y equals x. Well, we've talked about slope-intercept form before, right? We just got done doing it in the last chapter. So when I graph slope-intercept form, my slope's the number in front of x, my y-intercept's the number at the end. Well, in this case, there is no number in front of the x. This is slope-intercept form, but what would my slope be assumed to be here? 1. What's my y-intercept? 0. Okay? So I could write this as 1x plus 0. I don't necessarily need those things in there because they're assumed to be there. Okay? But you could write that in. The reason I tell you that is so you kind of understand where this line is going to be at. When we graph this, we're going to start at 0, and we're going to go up 1 and over 1. So it's going to be a line with some slope to it. Okay, another thing that I will tell you about this, and this is another thing that you will know about this now too, is if I have the line y equals x, look at the points that are on this line. What ordered pair is this? 1, 1. This is 2, 2, 3, 3, 4, 4. So every point that's on that line is the same, right? 1, 1, 2, 2, 3, 3, 4, 4. All of those points are the same. X and y are equal to each other. Okay? So that's another way you could do it if you want to graph it. Okay? Just kind of understanding what's going on. So either use slope or just understand that those two are the same. So when I reflect this, there's a couple of different ways you could do this, okay? But if you go back to, so in this case, we got F prime and we got G prime. Okay? If I'm going to do F prime, I'm going to take my original ordered pair and I'm flipping it around. So it's going to become 2, -1. So what do you think G prime is going to be? 2, 1. Yep, just changes places. So if I go 2, -1 and 2, 1, this is F prime, this is G prime, and there's my segment. Okay. These have been reflected, these have been reflected, okay? What makes this difficult is because the line is slanted. So knowing that rule is going to be really, really important, okay? Okay, the line y equals -x. So let's graph the same coordinates here. -1, 2. 1, 2. Here's F, here's G, makes a segment. Okay, when I graph the line y equals -x, how do you think that's going to change my line? It's going to go the other way, right? It's going to, instead of having a slope of up 1 over 1, it's going to go down 1 and right 1. So basically it's going to go from one corner of the box to the other. So there's your line. Instead of going up and to the right, now it's going down and to the right. Same thing, it's going to have a slope to it, but it's going the opposite direction because this line has a negative slope, right? Slope is negative, so it goes down instead of up. Now, the rule here, and I'm going to write this again, switch the ordered pairs. For this one over here, switch the ordered pairs. And opposites. Okay, so we got two things that we have to do here. So if I take -1, 2, and flip it around, and then I'm going to switch signs. So basically it's this ordered pair here, except we do the opposite sign for both. So this would become -2, +1, and this one becomes -2, -1. Okay, now let's see what happens when we graph this. -2, 1 is going to be right here. That's F prime. -2, -1 is right here. Hey, when I graph that, guys, here's what you have to pay attention to is, does it look like it's been flipped over, right? If I draw this reflection line in here, if I were to take that red segment and reflect it over, now it's up and down instead of left to right, okay? Just the opposite of what we had over there. So it has to look like it's been flipped over that line. If I take it and reflect it over, it's got to be on the other side of that line, okay? And it's going to be in a different direction. Hungry baby, huh? Okay. Questions about those two? All right, I think for right now I'm going to skip. The x-axis and y-axis is pretty straightforward. Maybe we'll come back to that on Tuesday. try doing both of these, okay? Kind of like we did in the last couple. Draw a picture of the two, okay? They're not the same triangle, so be careful with that. Okay, I'm going to do it as you guys do it. So try to draw it. Draw the line y equals x and y equals negative x in. Use the last one that we just did to help you out if you need to. We'll do these two and we'll see where we're at time-wise. Okay. Here are what your two pictures should look like. Okay, I also wrote the ordered pairs over here. For this one up here, all we did was take the ordered pairs and flip-flop. Okay, x becomes y, y becomes x. 6, 2 becomes 2, 6. Notice what happens with 4, 4. 4, 4 was right on the line, right? Nothing happened to it. It's right there where it was. Because when I switched 4, 4 around, still 4, 4. 3, 1 becomes 1, 3. Down here, I flipped them around and I switched the sign. So this was at 1, 3. So now it's at negative 3, negative 1. The points traded places and we switched the sign. 4, 4. When you flip 4, 4, it doesn't change anything, but they're both negative. So now it's negative 4, negative 4. And here, 3, 1 becomes negative 1, negative 3. Okay. And one really important thing, and I'm going to keep mentioning this, is when I'm done, I've got it has to make sense, right? The picture, if I were to take the picture and flip it over that line, it has to look like it's flipped over that line. If it doesn't, that means I've plotted it wrong. The two figures should be the same size, the same shape, okay? If you got a really big triangle and a really small triangle, something's not right, okay? So make sure your picture looks right. I can tell that this triangle has been flipped over this line because it works, right? If both your triangles end up on this side of the line or something like that, then you've done something wrong. So make sure your answer makes sense, just like when we're solving an equation. Does my answer make sense? It's a little bit different here because we're graphing, but it's still the same idea, okay? You got to make sure your answer makes sense. Okay. In this case here, we're going to look at a figure that has line symmetry. Okay, when we talk about symmetry, we've talked about symmetry before. Okay, example I always use is our bodies are symmetrical. Right, if we were to like slice this right down the middle, we got an arm, we got eyes, we got ears, we got legs. Our bodies are symmetrical. Okay, it's the exact same thing on the left as it is the right. Okay, maybe not like if you have like a birthmark or something like that, that may not be symmetrical, but all of our body parts are symmetrical. And that's what we talk about when something has a line of symmetry. So like in this case here, if you draw a line right through this butterfly here, this butterfly is symmetrical, okay? Would it be symmetrical if I drew a line this way? Could I take the bottom half of the butterfly and flip it on top of the top half? No, they're not the same size, right? So we can't draw a line of symmetry. If I had a pizza, I could take that pizza and cut it any which way. As long as I cut it evenly, then I could do all kinds of lines of symmetry through that pizza because it's a circle, right? So that's what we talk about when we talk about a reflection line is a line of symmetry. A figure can have more than one line of symmetry. That's kind of like what we were talking about a pizza. As long as I make even slices right down the middle of the pizza, now usually we don't like measure it out. Sometimes pizza slices don't always end up the same, right? But if I were to cut it exactly down the middle, I could make all kinds of different lines of symmetry, right? If you were to cut a pizza into 8 slices, then there would be 4 lines of symmetry. I could go vertical, I could do horizontal, I could do diagonal each way, or if I wanted to do really small slices, then I could start cutting other directions too. And I could make like 16 even pieces if I had 16 lines of symmetry, right? Then it wouldn't be very big pieces of pizza though. So we can have one line of symmetry, we could have no lines of symmetry, we could have a bunch of lines of symmetry, depending on what the figure is. Okay, so here we have 3 different kinds of polygons. We already talked about the butterfly. Trapezoid. Does the trapezoid have a line of symmetry? Okay, would that line of symmetry go vertical or horizontal? Vertical, yep. So it's going to come right down the middle. And the way we know this is, and it's hard, I mean, we're not going to actually measure it out, but we're going to draw a line right down the middle. This point can reflect over here, this point can reflect over here. It wouldn't do that if I went this way, right? Because this point would reflect up here and it would not land on the figure, okay? So in this case, this one has one line of symmetry. Okay, a regular hexagon. As I draw lines of symmetry here, would that be a line of symmetry? Still got 5 minutes left. Oh, okay. Okay, that would be a line of symmetry. Vertical and horizontal would be okay, right? And that's the one most people think of when they think of lines of symmetry. Would that be it? Where else could I draw a line of symmetry?
Between the middle of every line and between every
Point, vertice, yep. Okay, so I could do one like this. Because what I'm doing is I'm splitting that figure right in half, okay? I could go through the other vertices, and I could go like that. Okay, I could go through the middles of each side, So I could go like that, or I can go like that. Okay, each one of those is a line of symmetry. So how many lines of symmetry do we have here? A lot.
6.
6, yeah. So here we have 6 lines of symmetry. Okay, what about this parallelogram here? If I draw a line like this, is that? No. Okay. What about if I went diagonally like this? Okay, think about this. Where would this point have to go? Well, I'm going to reflect this directly across that line. So when I reflect this point over here, does it land on the shape? No. Okay, same thing here. This one reflects up here, doesn't land on the shape. Okay, because it has slanted sides, that doesn't work. Does it work going this way? Okay, if I were to reflect this line over this, it would land up here. Okay, this one reflected over would land down here, right? So what do you think we would say about this parallelogram? No lines of symmetry. Don't get to say undefined for this one. All right, so here's what I want you to do. We will talk about it on Tuesday. See if you can draw in all the lines of symmetry for these 3 figures right here. Really, it's just these 2. And this one, tell me which one has no lines of symmetry. Okay? You don't necessarily have to do 4-2 homework if you want to start doing it. We haven't gone through everything yet. So you can start on it if you want to. But we are not quite done yet.